My name is Peter Thomas, President of Resource Compliance. This short video provides an overview of IIAR Standard 9, which was published in March of 2020. To provide a bit of context, the document is named Standard 9 because it is IIAR's 9th published ammonia refrigeration standard. This standard represents a significant milestone for our industry as we can celebrate the completion of IIAR's suite of standards which address all aspects of ammonia refrigeration from design through decommissioning. The title of Standard 9 is Standard for Minimum System Safety Requirements for Existing Closed-Circuit Ammonia Refrigeration Systems. Like all other IIAR standards, Standard 9 was published to address a specific need in our industry. The motivation for writing a standard for existing systems was twofold. On the one hand, we wanted to prevent IIAR's design standard, Standard 2, from being used as a regulatory weapon against systems built before that standard was published. For example, the 2014 version of IIAR Standard 2 increased the minimum allowable design pressure of the low side of a system to 250 psi. However, many systems designed prior to that date utilized low side components that were designed for 150 psi. While it was never IIAR's intent that Standard 2 be used to forcibly require extensive upgrades to existing systems, many such instances have occurred. On the other hand, as an industry, we acknowledge that existing systems do contain risks that may affect employees and the community at large. In other words, it's unacceptable to use old age as an excuse for doing nothing. IIAR Standard 9 was written to address the tension held by these two perspectives. A simple way to think about Standard 9 is as a less stringent version of IIAR Standard 2. Standard 9 contains 8 normative chapters and 6 appendices. The normative chapters establish minimum requirements for existing systems and use words such as must and shall. These chapters are intended to be mandatory. The appendices are informational and contain non-mandatory content that complements the normative chapters. Chapter 7 is titled Minimum System Safety Requirements Applicable to All Systems and contains most of the requirements for existing systems. The biggest implication of this standard is in Chapter 8, which requires systems to be evaluated against the minimum requirements of Chapter 7 within 5 years from the date of publication. Appendix E provides an evaluation template that can be used if desired. Now I'd like to take a closer look at the details in Standard 9. We'll examine the content in Chapters 1 through 6 and Appendices B, C, and F. While that may appear to be a lot of information, you'll see shortly that these sections contain a relatively small amount of content. Chapter 1 establishes the purpose and scope of Standard 9. Section 1.1 succinctly states that the purpose of the document is to provide the minimum safety requirements for existing closed-circuit ammonia refrigeration systems. The key word in that sentence is existing. This standard is not applicable to the design or installation of new systems. Section 1.2.1 summarizes the scope of Standard 9 as providing a method to determine if existing systems comply with the minimum system safety requirements of the standard. Chapter 8 and Appendix E are wholly devoted to this subject of minimum system safety evaluations, so we'll table this topic for now and address it in a later training. Additionally, the scope of Standard 9 is to provide a method to determine and document that existing equipment designed and constructed in accordance with codes, standards, or practices that are no longer in general use is inspected, tested, maintained, and operating in a safe manner. In other words, IIAR 9 provides a method for our industry to demonstrate compliance with the process safety information requirement in the PSM, RMP, and CalARP regulations. Standard 9 is not applicable to equipment in non-industrial occupancies, such as low-charge systems that are now being used in the commercial sector. Additionally, this standard does not apply to ammonia absorption systems. Chapter 2 is titled Definitions and directs the reader to IIAR Standard 1, which is titled Definitions and Terminology Used in IIAR Standards. The only new definition introduced in Chapter 2 is Risk Ranking Method. But since that definition relates to minimum system safety evaluation methodology, we'll wait to examine it until Chapter 8. Chapter 3 lists the normative references that are part of Standard 9. The documents listed are the ASME Boiler and Pressure Vessel Code Section 8, OSHA's regulations relating to machine guarding, IIAR Standards 1, 2, 6, and 7, the International Safety Equipment Association Standard for Emergency Eyewash and Shower Equipment, and NFPA Standard 704. which explains the 4-quadrant placarding system for hazardous materials. Appendix F lists additional references that are informational. This slide displays the content included in Appendix F. Chapter 4 clarifies the minimum requirements for equipment and system documentation. The required documentation is divided into 3 categories: manufacturer data reports, materials of construction, and manufacturer documentation for system components. You probably noticed the asterisk in each of the 3 categories. Whenever you see an asterisk in this standard, it means that there is additional explanatory material regarding that section in Appendix A. This slide displays the explanatory material for section 4.1.2 regarding materials of construction documentation. As you can see, the first paragraph explains what materials of construction documentation is and even provides a list of common types of materials of construction documents. The final paragraph has an interesting statement regarding Appendix C. It states that Appendix C provides a listing of additional equipment system component documentation that is not required by this standard to be obtained to demonstrate compliance. Appendix C is located near the end of the document and provides even more background material regarding documentation. The paragraph introducing Appendix C is intentional in clarifying that the appendix is not mandatory. This is true for all the appendices in Standard 9. The first sentence of the second paragraph explains that the purpose of Appendix C is to provide a listing of equipment documentation that is not required to comply with the standard, but may be beneficial in developing other regulatory documents. The appendix continues by providing a myriad of examples of such documents. In terms of PSM, each of these is an example of a process safety information document. We won't look at each item in this list, since the documents are not required to comply with Standard 9. Appendix B is titled Equipment System Component Documentation and serves a very similar purpose as Appendix C. Like Appendix C, Appendix B is merely informative. Appendix B uses a similar sentence as Appendix C to state that the purpose of the appendix is to list documents that are not mandatory to comply with Standard 9, but are required to demonstrate compliance with other regulatory requirements. Appendix C concludes by listing 10 documents which are required in the RMP, PSM, and CalARP regulations as part of process safety information. Chapters 5 and 6 are incredibly brief, consisting of 1 sentence each. Chapter 5 requires that equipment and system components be inspected, tested, and maintained in accordance with IIAR's ITM standard, Standard 6. An interesting nuance of this section is that 5.1 seemingly requires existing systems to comply with Standard 6 immediately, whereas Section 4.1.3 of Standard 6 states that the standard is voluntary until adopted by the authority having jurisdiction or when adopted by the owner, whichever comes first. We'll have to wait and see how this subtle difference plays out. Chapter 6 requires that existing systems develop operating procedures that comply with IIAR Standard 7. Now I'd like to jump ahead and look at Chapter 8. Chapter 8 explains the requirements for evaluating existing systems against the minimum requirements of Chapter 7. Appendix E provides an example of a minimum system safety evaluation that can be used as a template. You may recall that earlier in the document, the scope of Standard 9 was defined in part as providing a method to determine if existing systems comply with the minimum safety requirements of the standard. Chapter 8 contains the prescriptive requirements for this methodology. Chapter 8 has 3 sections which address requirements, methodology, and frequency. The phrase minimum system safety evaluation is used 9 times in Chapter 8, and therefore it's worthwhile to add another acronym to our vernacular. Moving forward, a minimum system safety evaluation will be referred to as an MSSE. The big idea of this chapter is that it is mandatory to perform regular MSSEs to evaluate existing systems against the requirements of Chapter 7 of this standard. Section 8.2.1 prescribes that Standard 9 be used as the measuring stick for existing systems. New systems, however, should not be evaluated using this standard, and instead should be evaluated using the latest version of IIAR's design standard, Standard 2. An MSSE must include at least the following aspects: a documentation review, minimum system safety requirements review, and a physical system inspection. The purpose of each of these is to identify gaps which exist between the requirements of Standard 9 and the system configuration. As expected, the results of the MSSE and the procedures that were used to identify gaps must be documented. The documentation must specify the actions that will be taken to address each gap. When a gap is closed, the documentation should summarize what was done to correct the deficiency. If the facility declines to close an identified gap, further justification is required. Standard 9 lists 4 options to provide justification for declining to close a gap. The options are a semi-quantitative technique, an analytical tool, a quantitative risk analysis, or a variance from the authority having jurisdiction. It is beyond the scope of this video to explore each of these in detail, but Appendix A provides a helpful explanation on each. An example of a semi-quantitative technique is the What-If Checklist PHA methodology. What-If Checklist PHAs use risk-based rankings which are somewhat subjective, hence the semi and semi-quantitative. Layer of protection analysis, or LOPA, is given as an example of an analytical tool in Appendix A. According to the appendix, LOPA is a simplified method of risk assessment that provides the much-needed middle ground between qualitative PHA techniques, such as what-if checklist analysis, and a traditional, expensive, quantitative risk analysis, such as fault tree analysis. Fault tree analysis is an example of a quantitative risk analysis that could be utilized to decline to close a gap. In short, fault tree analysis is a deductive technique that focuses on a particular occurrence of a system or component failure and provides a method for determining the causes of that event. Arguably, the biggest implication of Standard 9 is that MSSEs must be performed initially within 5 years of the document being published. This means that the first MSSEs are due in March of 2025. It is expected that initial MSSEs will be revalidated every 5 years. Because MSSEs share the same revalidation frequency as PHAs, Appendix A suggests performing MSSEs in conjunction with PHAs. Several of the prescriptive requirements in Chapter 8 are also included in Chapter 1. The table on this slide demonstrates the similarities between Chapter 1 and Chapter 8 relative to performing initial MSSEs, revalidation frequency, and methodology. Informative Appendix E contains a sample format that can be used or modified to document MSSE findings. We'll conclude our study of Standard 9 with a survey of Chapter 7. Chapter 7 is by far the longest chapter in Standard 9 and contains the minimum system safety requirements that are applicable to all systems, regardless of when they were built. Chapter 7 has 4 sections which address location of equipment, general system safety requirements, machinery room requirements, and general equipment safety requirements. We'll start by exploring the requirements in Section 7.1 and 7.2. Section 7.1 addresses the permissible locations to install ammonia refrigeration equipment. Like Standard 2, Standard 9 expects that refrigeration machinery will be installed inside a machinery room. However, Standard 9 allows for several exceptions. First, equipment may be installed outdoors. Second, select equipment may be installed in other than machinery rooms. Examples of such equipment are evaporators, condensers, low probability pumps, valves, and any ammonia refrigeration system or portions thereof with a total connected compressor drive power not exceeding 100 horsepower. Section 7.2.1 prescribes the purity requirements for ammonia used in a refrigeration system. The purity specified in Standard 9 matches Standard 2 for new designs and must have an ammonia content of at least 99.5%. Contaminants must be limited as specified in the table on this screen. Section 7.2.2 addresses the minimum pressure ratings that are acceptable for existing systems. As the table illustrates, Standard 9 is more lenient than Standard 2 in allowing the low side design pressure to be 150 psi, as opposed to 250 psi in Standard 2. While it should go without saying, Section 7.2.3 requires that existing equipment be rated to operate within the full range of temperatures associated with the system rating and for the full range of ambient temperatures to which the equipment will be exposed. You can determine the maximum and minimum temperature ratings for a vessel by reviewing its data report. Section 7.2.4 requires that systems be configured with a means to remove air and other non-condensable gases from the refrigeration system. Typically, condensers are configured with purge valves on the condenser drain piping to facilitate purging of non-condensable gases, as shown in the picture on the left. Occasionally, however, you'll run across a system lacking these valves, as depicted in the image on the right. Section 7.2.5 addresses oil management and requires that provisions be made for removing oil from locations in piping and equipment where oil will accumulate. Specifically, it requires that compressors be configured with a means to sample oil for periodic analysis and that oil removal be accomplished by one of 3 approved means. The picture on the right shows a standard oil pot with a self-closing deadman valve, which complies with the requirements of Standard 9. Other approved means for oil removal include a rigid piped oil return or transfer system, or a valve and piping assembly at the draining point where oil is removed from the system. At minimum, a shutoff valve in series with a self-closing shutoff valve is required. Appendix A clarifies that oil draining valves and piping can be either permanently installed or temporary. Either is acceptable. Standard 9 requires that piping and equipment surfaces not intended for heat exchange be insulated, treated, or otherwise protected to mitigate condensation and excessive frost buildup. This section exempts valves and other equipment from requiring insulation where insulation would restrict access to the component. Also, pipes and fittings constructed of corrosion-resistant materials or protected with a corrosion-resistant treatment need not be insulated so long as they are routinely defrosted to limit ice accumulation. Section 7.2.7 requires that piping, tubing, and equipment be supported to prevent excessive vibration and movement. Section 7.2.8 addresses service provisions and requires that equipment be accessible for inspection, testing, maintenance, and emergency shutdown. Charging connections must be plugged or capped when not in use. If located outdoors, the connection must be locked or otherwise restricted to access by authorized personnel only. This section ends by laying out the requirements for pressure gauges on the high side of the system. They must display at least 120% of the design pressure, and this section also requires that equipment have isolation valves for service and a means for pump out. With regard to signage and labeling, Standard 9 closely matches Standard 2. Machinery rooms must be equipped with NFPA 704 placards, alarm signage, and restricted access signage. Equipment must be provided a label indicating the equipment ID number. Valves intended for emergency shutdown must be clearly and uniquely identified at the valve and on schematic drawings. And finally, all pipes must be labeled. Section 7.2.10 states that it is the duty of the person in charge of the premises to provide directions for emergency shutdown that are readily available. This information must include details and steps for shutting down the system in an emergency, name and telephone numbers for operating and maintenance staff, names and numbers of government agencies that must be notified of a release, quantity of ammonia in the system, and emergency facility contact information. Where used, equipment enclosures must be provided with protection from physical damage and equipped with panels or doors as needed to operate and maintain the equipment. Section 7.2 concludes by addressing some general safety requirements that are applicable to all equipment, regardless of age. For example, any equipment subject to physical damage must be guarded or barricaded, and equipment with moving parts must be protected by screens or guards in accordance with OSHA rotating machinery regulations. Continuing on, let's consider the requirements of Section 7.3. Relative to machinery room construction, Section 7.3.2.1 requires that the machinery rooms be separated from other portions of the building by tight-fitting construction. The unsealed hole in the wall in this picture is prohibited by IIAR Standard 9. Pipe and equipment supports must be adequate and designed to carry the weight of the equipment, ammonia inside the equipment, and insulation. Standard 9 indicates that where necessary, sway bracing and vibration control are required, but the document does not specify what circumstances would make bracing necessary. Section 7.3.3 requires that equipment installed in the machinery room be arranged to allow egress from any part of the room in an emergency, as depicted in this image. Manually operated valves that are inaccessible from the floor must be made operable from portable platforms, fixed platforms, or chain operated, as shown in these images. Valves referenced in emergency shutdown procedures, such as king valves, must be directly operable from the floor or chain operated from a permanent work surface. Section 7.3.3.4 requires that access to machinery rooms be restricted to authorized personnel only. Informative Appendix D includes an example of how to label a machinery room door. Storage of combustible materials inside a machinery room is prohibited except when stored within a fire-rated cabinet. The images displayed are examples that do not comply with the requirements of Standard 9. Standard 9 prohibits the installation of fuel-burning appliances and equipment with surface temperatures above 800 degrees Fahrenheit inside machinery rooms. Exceptions are made if the combustion air is ducted from outside the machinery room or if the equipment is interlocked with ammonia detection. Internal combustion engines powering ammonia refrigeration compressors are permitted to be used in a machinery room. Any pipes penetrating the machinery room envelope must be sealed. Use of netting or fences as displayed in this image is not allowed. All ammonia pipes must be labeled. The label must include the word ammonia, the physical state of the ammonia in the pipe, the relative pressure level in the pipe as being low or high, the pipe service, which is typically an abbreviation, and the direction of flow. Ammonia cylinders must not be connected to the refrigeration system unless in the process of being transferred from a cylinder into the system. Standard 9 matches the requirements in Standard 2 for eyewash and safety showers. Each machinery room must have access to a minimum of 2 eyewash and safety showers, one inside the room and one outside the room. Additional units are required to ensure the path of travel in the machinery room to an eyewash and safety shower is no more than 55 feet. Eyewash and safety showers installation must adhere to ANSI ISEA Z358.1. Standard 9 prescribes that floor drains or other means be provided to dispose of liquids. The term other means is not defined, leaving quite a bit of flexibility to achieve compliance. Section 7.3.9 requires that machinery rooms exceeding 1,000 feet squared have at least 2 exit doors. Appendix A provides explanation that where installing a second door is impractical, the owner or operator should provide an alternative escape method, such as the use of escape equipment. Machinery room doors must be self-closing, tight-fitting, equipped with panic hardware, and swing in the direction of egress. Section 7.3.10 requires that machinery rooms be equipped with light fixtures which can deliver a minimum of 30-foot candles at 36 inches above a floor or platform. There are numerous smartphone apps that can be used to measure the light intensity inside a machinery room. Existing facilities must have an emergency stop switch and ventilation switch located outside the principal machinery room door. The e-stop must provide off-only control of compressors, ammonia pumps, and normally closed automatic valves located inside the machinery room. The ventilation switch must provide on-auto override capability for emergency ventilation. An emergency ventilation switch is not required if the ventilation system runs continuously at the emergency ventilation rate. Both switches must be protected by a tamper-resistant cover and clearly marked by signage near the controls. IIAR 9 requires that existing machinery rooms be provided with ammonia detection and alarms. At least one detector must be installed. The alarms must report to a monitored location if the concentration reaches 50 parts per million so that corrective actions can be taken. If the concentration reaches 1,000 parts per million, emergency ventilation must be activated. The refrigeration machinery room equipment must be de-energized if the concentration reaches 40,000 parts per million. Standard 9 specifies that audible and visual alarms are required both inside and outside the machinery room. There is no requirement in Standard 9 to provide detection outside the machinery room, although Appendix A warns that ammonia detection may be required in areas other than machinery rooms by the building code, fire code, or mechanical code in effect at the time of installation. Section 7.3 concludes by addressing machinery room ventilation. At minimum, existing machinery rooms must be provided with occupancy ventilation and emergency ventilation. IIAR 9 does not specify the required ventilation airflow rates, but rather requires compliance with the codes and standards in effect at the time of construction or modification to the machinery room. Other ventilation system requirements include the system must be automatically activated if the ammonia concentration reaches 1,000 parts per million, fan blades must be non-sparking, fan motors in the airstream must be totally enclosed, a monitored location must be notified if the ventilation system fails, makeup air must prevent short-circuiting, be uncontaminated, and serve only the machinery room, and where utilized, motorized louvers must fail open. To finish up our study of Standard 9, let's look at the requirements of Section 7.4. Standard 9 requires that ASME vessels and heat exchangers be protected from overpressure with an ASME relief device. While Standard 9 does not include prescriptive requirements for sizing relief valves or termination piping, it does mirror Standard 2 in requiring that relief valves terminate to atmosphere at least 15 feet above grade and 20 feet from a window, ventilation intake, or exit door. If the termination point is on the roof, the termination height can be reduced to 7.25 feet if that roof is occupied solely during service and inspection. This same requirement is applicable to platform surfaces, such as condenser platforms. IIAR 9 requires that relief valve piping be configured with provision for draining moisture from the piping. Where a liquid can be trapped and cause overpressure due to thermal hydrostatic expansion, overpressure protection must be provided. The images on this slide illustrate two different types of hydrostatic relief devices. Standard 9 requires a hydrostatic relief device when liquid can become trapped in any of the following scenarios. 1. Automatically during normal operation. 2. Automatically during shutdown, including an alarm or power failure. 3. During planned isolation for standby or seasonal conditions. 4. Due to an equipment fault. Or 5. Refrigerant pumps and connected piping must have a means of protection from hydrostatic overpressure. IIAR 9 clarifies that if hydrostatic expansion is only possible during maintenance or service operations, administrative controls are acceptable in lieu of a relief device. Section 7.4.4 requires any vessel connected directly to a compressor suction line to be equipped with a high liquid level control to cause the compressor to shut down if high liquid level is detected in the vessel. Similarly, Section 7.4.5 requires compressors to be configured with a high discharge pressure limiting device, often called a high pressure cutout, to shut down the compressor when the safe range is exceeded. The location of ammonia piping is restricted in Section 7.4.6. Piping must not obstruct a means of egress. Piping must not be placed in a shaft containing a moving object, such as an elevator. Piping must not be in a means of egress that is enclosed and accessible to the public. Piping can be installed underground so long as it is protected from corrosion. And finally, where piping is installed in concrete floors, it must be encased within a pipe duct. Standard 9 requires instrumentation and controls to be provided to indicate the operating parameters of the refrigeration system and equipment. Standard 9 matches Standard 2 in requiring facilities to have a method of monitoring the concentration of ammonia during a power failure. Appendix A suggests that a portable ammonia detector is an acceptable means to adhere to this requirement. Refrigeration system safety settings must be limited to authorized personnel only. This is often achieved through password protection on a PLC HMI. Any instruments and visual level indicators must have a maximum allowable working pressure equal to or greater than the system in which they are installed. Section 7.4 concludes by addressing visual level indicators. First, sight glasses must not be installed where risk of hydraulic shock exists. Second, all level indicators must be protected from physical damage. Third, with the exception of a bullseye column, linear level indicators must be fitted with internal check-type shutoff valves and have protection against accidental breakage of the glass tube from any direction. And finally, when bullseye sight glasses are used, they must be compatible with ammonia and sized for the intended application. I trust you found this training on Section 7.4 of IIAR 9 helpful. I welcome any questions or comments that you might have. Feel free to reach out to me using the contact info on the screen. Thank you.